We're about to challenge one of the most deep-seated beliefs we have about the modern world, the idea that nuclear power is uniquely dangerous. So for a moment, let's just try to put aside everything we think we know and look at what the raw data actually tells us. Because honestly, the answer's pretty shocking.
Okay, let's just dive right in with a simple question. If I asked you to name the most dangerous way to make electricity, what's the first thing that pops into your head? For most of us, one word just immediately comes to mind: nuclear.
And it's really no wonder why, is it? I mean, decades of pop culture have hammered these images into our brains. We picture these terrifying monsters rising from the sea, those glowing green rods, and we have this primal fear of radiation itself. It feels deeply intuitively dangerous.
So, here's how we're gonna break this down. First, we'll talk about that Godzilla effect. Then we'll look at the real danger ranking, using hard data. We're gonna uncover a silent killer, explore a big mistake our brains make when judging risk, debunk the nuclear waste myth, and finally, we'll put data over drama.
So this powerful perception, we can call it the Godzilla effect. Our fear is really shaped by these unforgettable, horrifying disasters like Chernobyl and Fukushima, right? These events are just seared into our collective memory, and they create this story that nuclear energy is uniquely catastrophic, an invisible, uncontrollable form of death.
Okay, but to get past feelings, we need cold, hard facts. And if we're gonna compare different energy sources fairly, we can't just count scary headlines. We need a standardized metric, something that puts everything on a level playing field. And that metric is deaths per terawatt hour. Now, think of it like deaths per million miles driven for cars. It's the same idea. A terawatt hour is a huge amount of energy, enough to power a big city for about a year. So this lets us compare the human cost of keeping our lights on, apples to apples. So, what happens when we actually apply this metric? Well, the results are stunning. Over on the far left, you've got coal, causing about 24.6 deaths for that unit of energy. Next to it, oil at 18.4. And then, all the way over here, you have nuclear at just 0.03. The difference isn't just big, it is absolutely staggering. Let's really put that into perspective. When you factor in everything from accidents to long-term pollution, this data shows that nuclear power is about 820 times safer than coal. 820. Statistically, that puts it right up there with wind and solar as one of the safest energy sources we have, period.
So this raises a massive question, right? If nuclear is so safe according to the numbers, why are the fuels we use every single day, coal and oil, so unbelievably deadly? Well, the answer isn't in some big dramatic explosion. It's in something much, much quieter.
The real danger, the real killer, is air pollution. See, when you burn fossil fuels, it releases these microscopic particles called PM 2.5. They are so tiny they just bypass our body's natural defenses, lodging deep in our lungs and even getting into our bloodstream. And over time, this is what causes chronic diseases like asthma, heart disease, and lung cancer.
And the scale of this problem it's almost impossible to wrap your head around. Globally, it's estimated that air pollution from burning fossil fuels kills 8 million people every single year. This isn't some one-time catastrophe. It is a constant, relentless crisis happening right now.
So here's the way to think about it, and this is the crucial point. The number of people who die from fossil fuel pollution every single day absolutely dwarfs the total number of deaths from all nuclear accidents in history. It's like having a Chernobyl-scale disaster happening daily. But because the deaths are quiet, spread out in hospitals around the world, it never makes the 6 o'clock news.
So if the data is this clear, why do our brains get it so completely backward? Well, the answer isn't in physics, it's in psychology. It turns out we have this built-in glitch in how we think about risk.
It's a cognitive bias called the availability heuristic. Basically, our minds judge how likely something is to happen based on how easily we can remember an example of it. And, dramatic, terrifying, headline-grabbing events are way easier to remember than slow, common, everyday dangers.
This analogy just illustrates the idea perfectly. Think of coal's air pollution like car crashes. They kill a huge number of people constantly, but because it happens one or two at a time, we kind of see it as a normal, acceptable risk. Now, nuclear accidents, those are like plane crashes. They are incredibly rare, but when they happen, they're spectacular, they're terrifying, and they dominate the news for months. Our brains are wired to fear the plane crash, even though we're thousands of times more likely to die in the car. Okay, I can hear you already. But what about the waste, right? This is always the final argument against nuclear power. Isn't it this permanent, toxic problem that we just can't solve? Well, let's actually look at the reality of it.
When you compare the two, the reality is kind of surprising. Nuclear waste is a solid. We know exactly where all of it is. It's stored in these unbelievably durable concrete and steel casks, and it's carefully monitored. Coal's waste, on the other hand, it's a gas. It's just dumped directly into the atmosphere. You know, the air that we all breathe.
And here it is. This is the ultimate irony. Get this, coal naturally contains trace amounts of radioactive elements like uranium. When you burn it, those elements get concentrated in the ash and then released. Because of this, the fly ash coming from a coal plant is actually more radioactive than the area around a properly functioning nuclear facility. Wild, right?
So what does this all mean for the choices we make about our energy? It means we have to consciously decide to prioritize data over drama. We have to choose statistics over scary stories. So let's just quickly recap the key takeaways here. First, our fear of nuclear is really driven by our psychology, not by the data. Second, the real catastrophe, the true silent killer, is the daily grind of air pollution from fossil fuels. Third, when you just look at the numbers, nuclear is one of the safest energy sources we've ever invented. And finally, and this is a tough one, shutting down safe nuclear plants has often forced us to rely more on deadly coal, which tragically causes far more harm.
And all of that leaves us with one last question to think about. When the data on safety and on human lives is this unambiguous, what's the real price we pay in lives and in the health of our planet for letting our primal fears, instead of the facts, guide our most important decisions?